Hello, I'm Teacher Ivan from WUNNA Educational Services. You are most welcome to our second lesson of linear motion. Previously, we looked at how we derive the three equations of a uniformly accelerated motion. We are to look at how we apply these three equations to solve mathematical problems. But before we look at the examples, we have some important notes to take care of. One is that the three equations, the one we derived previously, apply only to uniformly accelerated motion. Two, when the body starts from rest, then the initial velocity u equals to 0. And when it comes to rest, then the final velocity v equals to 0. And the acceleration can be positive or negative. If it is positive, that means that the car's or the body's speed or velocity is increasing in equal time interval. Then if it is negative, then it is known as retardation or deceleration, which means that the car is coming to rest. Let us look at examples. Example 1 says, a car moving with a velocity of 10 meters per second accelerates uniformly at 1 meter per second squared until it reaches a velocity of 15 meters per second. The question is, calculate the time taken, distance traveled during the acceleration, and the velocity reached 100 meters away from the place where acceleration began. So, if we look at our question, we are given the initial velocity u as 10 meters per second. We have the acceleration as 1 meter per second squared, and the final velocity v as 15 meters per second. We need time. So if we look at all the three equations, time can easily be derived using the first equation. That is to say, v equals to u plus at. We have v as 15, we have u as 10, we have acceleration as 1, therefore we can get time. When we substitute and evaluate, we come up with t as 5 seconds. That is how we shall find the time taken. Then we come to the distance traveled. If we look at all the three equations, distance can be calculated using the second equation or the third equation. So since we have got time, therefore it is possible for us to use the second equation. However, my advice could be we use the third equation, because assuming the time you got in part A was not correct and you substitute it in part C or in part B when you're finding the distance, since you used the wrong time, therefore even the distance will be wrong. So to minimize the errors, we better substitute in the third equation, where we have the final velocity v, we have the initial, we have the acceleration, therefore we can get the displacement s. So once we substitute, we get v squared, which is 15 squared, then equaling to 10 squared plus 2 times 1 times the distance traveled, which gives us the distance as 62.5 meters. However, we can use the second equation and get the same distance. We have part C, which says calculate the velocity reached 100 meters from the place where acceleration began. So we shall be finding the final velocity, but we are given the distance as 100 meters. We have the initial, therefore we shall use the third equation to find the distance s. So try out that.